Hi everyone, today we will be doing a deep dive into DataRaptor Extract. We'll start by going over the use cases and learning about best practice when designing DataRaptor Extract. This will be followed by a quick walkthrough of the DataRaptor Extract Designer interface. I've also got some hands-on exercises for you and we'll be covering briefly on how DataRaptor Extract integrate with other OmniStudio components like OmniScript. I've also designed some hands-on challenges to help you put what you've learned in this video into practice. With this, let's get started. Now, before we dive into DataRaptor Extract, I would encourage everyone to check out our video on DataRaptor Turbo Extract, completed the hands-on exercises, and have a go at those hands-on challenges. The concepts covered in that video will set a solid foundation for what we're about to cover today. So if you haven't caught it yet, find the link in the description below and above. Now let's quickly revisit the basics. What exactly is a DataRaptor extract? So it's similar to DataRaptor Turbo Extract. It's like running a SQL query, but the main difference is that it can extract data from multiple Salesforce objects. So if you are preparing for the developer or consultant OmniStudio exam, pay attention to this slide. The concepts discussed here often pop up in the exams. Moving to use cases and best practice. We use DataRaptor Extract if you need to retrieve data from multiple unrelated objects. For example, if you need to fetch the account name field from account object and the user's email address from the user object. Or if you need to extract data from single or multiple child objects. For example, you need the account name field from account object and the first name field from all the related contact objects associated with the account, then you would use DataRaptor Extract. Or if you need to manipulate data with formula, for example, if you need to append the case number on the case object with the account name, for example. If you need to fetch data from a single object, like account name from account object, and not requiring formula, you can use DataRaptor Extract as well, but the best practice is actually to use DataRaptor Turbo Extract as it's simpler to configure and also has better performance at runtime. Another use case is that if you need to retrieve data from single or multiple parent objects, for example, if you need to fetch first name from contact objects and account name from the account associated with this contact object, you can use DataRaptor Extract as well, of course, but DataRaptor Turbo Extract will be a better option. Note that if you need to manipulate data with formula, you will have to use DataRaptor Extract as DataRaptor Turbo Extract does not support formula. Rule of thumb is that if you need formula function, use DataRaptor Extract. If you need to fetch multiple objects, use DataRaptor Extract unless these are related parent objects. Otherwise, use DataRaptor Turbo Extract for better performance and simpler configuration. All right, let's create the first DataRaptor extract together. Click on New. For this one, we'll be extracting account details. It's always good to follow a good naming convention. I always start with DR, followed by a prefix describing the type of DataRaptor, in this case extract, ext, and finally the object details. We'll be working with extract today. Keep the rest the same and always good to put some description in as well. Once you're in here, you'll notice that the interface between extract and turbo extract is very similar. The major differences are in the extract tab, there is the option to add multiple steps. So this allows you to extract data from multiple objects. You'll also notice that in Turbo Extract, you can select the fields in the Extract tab, and this is not available over here as for Extract because you can select multiple objects. There is more configuration to do, so this is where the Output tab comes in. It allows you to set up those mapping from different objects that you are extracting. There is the addition of the Formula tab that allows you to manipulate data using formulas. In terms of the Options tab, it's basically identical, but there is an additional option here, which we'll go over in detail shortly in the later part of the video. The Preview tab is basically the same. Up here in the highlight panel, you'll notice that there is an additional of this Quick Match button. Again, we'll go over shortly in the later part of the video as well. When I was learning about DataRaptors, figuring out how to use them in real life situations was really helpful. It really helped me out in implementing my first actual OmniStudio project and made quite a big difference in my certification prep, especially for the consultant exam that had a bunch of scenario-based questions. So I've got a scenario ready for you as well. So imagine you have a website powered by Salesforce Experience Cloud selling high-tech equipment to businesses. At the moment, to fill in the support form, which is already built using an OmniScript, your customers need to populate their company information even though they've already logged into the portal. So to improve your customer's experience, you are thinking about building a DataRaptor extract that would pre-populate the form with the company's information and other details. Now let's start preparing to build this DataRaptor extract. For this simple exercise, let's just assume that we only have one customer using the support form, which is Edge Communications, and we want to pre-populate the form with their account name, account number, an annual revenue, and their phone number, which is over here, using the DataRaptor extract. As mentioned earlier, that building a DataRaptor extract is like writing a SQL query. So let's try one first. Select ID, name, account number, annual revenue, phone from account where name is Edge Communications. When we run this query, this is basically the result we'll be expecting in the DataRaptor response, but you'll be in a JSON format. So if you are new to OmniStudio or DataRaptor, I will highly encouraging you to build a query first, as this will help you build a good picture of what the response will look like. Now let's start building the DataRaptor. First step, select the object, in this case account. Extract output path. So as mentioned in the DataRaptor Turbo Extract video, this extract output path is the JSON node in the output. So pay special attention over here. It's basically a container that stores the query result. Best practice is to name it in a way that indicates the object that's getting extracted from. I usually go with lowercase and plural to distinguish this with the object name. So as I entered accounts in the extract output path, you can see the extraction step over here, and this has populated with JSON with accounts being the node. Filter. This is where you'll be selecting the field you want to use as a condition for the query. So in SQL query, this is the but after where. In this case, we want to use name. And these fields are, you can find all these fields in the object manager under account. Operator, in this case, we'll be going for equal. And condition is Edge Communication. And notice the quotation mark here because it's not a variable, it's a literal text. So similar to DataRaptor Turbo Extract, there are condition options and or limit offset ordered by that you can add to your query. So now let's run it and have a look at what it looks like in the preview. You'll notice that there is no response, but the query is actually over here. Select name ID from account where name is Edge Communications, and it has found a query result. The reason for this is we actually haven't configured the fields that we need to display in our response, and this is actually configured in the output tab. So in this tab, we'll basically be telling the DataRaptor to extract information such as account number, annual revenue, and phone. Now let's set up some mapping so we can get something in the response section of the preview tab. To set up mapping, click on the plus icon here. There are quite a few things to configure here, and we will go over each of these in detail in later part of the video. But for now, let's just focus on the extract JSON path and output JSON path. Now, these might sound a bit confusing to start with, but they are not that complicated once you have practiced a few times. Let's have a look at the extract JSON path first. Notice here how all of the fields have the accounts node in the front. This node is actually what you have defined in the extraction step JSON, and this is coming from the extract tab under the extract output path. So notice how over here you have the extract step JSON here as well. So this here just makes your life easier, not having to flick between different tabs. So what we are basically doing here is specifying the fields we want to extract from the node we defined in the extract tab, in this case accounts. And you can think of this as setting up the first half of the so-called query. So in here we are specifying the fields that we need from the account object. And in this case, it's quite similar. We are extracting the fields from the accounts node. So let's start with getting the account name. In this case, the API name is just name. So let's type name in here. Select this one over here. So to help you understand this a bit better, if you think in container terms, what we are doing here is we are basically setting up a container called accounts. And within this account container, we are including a sticky note that says name. So in fact, we can change the name of this container to whatever we like. So if we change this to test, you'll notice that this has changed. And if we go back to the output node, you'll notice that if I put name in here, the node has actually changed to test. But of course, this is not practice. This is not good practice, as it's quite hard to know the object associated with this node. So let's just change it back to accounts. Now moving to the output JSON path. This is where you decide how the output JSON structure will look like. So we can compare this with the so-called query. We are basically in the export result section. And what we are doing in the output JSON path is to basically set up the name for these Excel columns. So in output JSON path, you can configure where to store the data you extracted from the extract JSON path. In this case, the name of the account. You can store this data inside another JSON node, or multiple JSON nodes, or in fact, without any JSON node. We'll talk about how we decide on the JSON node structure in later part of the video. So again, we can name whatever we like here, but best practice is to keep it the same as the field name. And good practice is to keep everything in output JSON path in lowercase to keep separate from the actual field name, which starts with a capital letter. So let's just keep it simple and copy the extract JSON path and paste it here and make the name lowercase and click on add. So notice how the current JSON output section is now displaying the accounts node, and within the accounts node there is the name attribute. So this is quite a good place to visualize what you've configured here and whether things are as expected. Now let's go to the preview tab and click execute. And now we're able to see the name from the account. So Edge Communications. So you can actually code the attribute whatever you like. If we change this to test, you'll notice the current JSON path has changed. And when we execute again, this has changed to test as well. So this is obviously not best practice, as it's quite hard to figure out what the field this attribute is related to. And notice how changing the attribute from name to test doesn't actually affect the query. The query is still using the name field. And this is because the query is associated with the extract JSON path, where the response is related to the output JSON path. So let's change it back to name lowercase and execute it again. So now this looks a lot better. So how do we actually decide on the output JSON path or the structure of our JSON output? So this actually depends on what application will be using the data extracted from this DataRaptor extract. So it comes down to how, for example, FlexCard integration procedure OmniScript is designed. If we design OmniScript as example, if we design OmniScript in a way that doesn't want the result to be wrapped inside any node, then we'll need to take away the account. And you'll notice that the current JSON output has changed. And when we go to the preview, the account node is gone. And if you design OmniScript in a way that requires multiple nodes, for example, form account name, then you'll notice the current JSON output is changed, and this will obviously change the structure of the response as well. So I'll be covering details about deciding what the JSON structure needs to be when passing data from DataRaptor to OmniScript, FlexCard, or integration procedures. So don't worry if this seems confusing at the moment. Things will make a lot more sense when you go over those videos. So to summarize, think of the current JSON output as a big dining table. And what we are doing here in the output tab is we are going to the account container, and inside this account container, we are taking out a sticky note with the name of the account written on it, and we are taking that out and deciding where to put it on the standing table. And we have quite a few different ways to do this. We can either put it just on the table, so that means without putting it inside any container. And what this looks like is just with a name attribute without any nodes. Or we can put it inside a container called accounts, or even putting it inside a container within another container. So in this case, the name attribute, it lives inside a container called accounts, and this lives inside another bigger container called forms. Let's now go back to the output tab and start adding these fields. So click on add, account number, and what we want to do is we want to change this to lowercase, add, and you'll notice something looking a bit strange over here. You have forms account name, accounts number in different JSON structure. That is because previously we've added another node over here. So to make sure everything comes on the same node, we'll just change this back by removing the forms node. And now this looks a lot better. Account number, and next up is annual revenue. Copy this, paste it here, change this to lowercase, and we want the phone as well. Phone, copy this, paste it here, change this to lowercase, add. And now in the current JSON path, you now have the accounts node with all the fields that you need. And when we go to preview, click execute, now we have all the field information from the Edge communication account record, and this looks pretty much like this, but in the JSON format. If we want to serve more customers than just Edge communications, we need to be a bit more dynamic. So instead of hard coding the account name, what we can do is we can add a variable. We'll call it account name. Notice how we don't need a quotation mark around this, as this is a variable, not a literal value. And if we go to preview, what we need to do is we need to, if we just execute now, we'll basically get nothing, we'll get an error because we haven't specified what goes into the account name. So we'll add a key value pair, put this in here. If we start with Edge communications, we should be getting the result that we had before. And now we can try with different account names, for example, University of Arizona, and now it's returning the details. What you might have noticed here is that the annual revenue attribute is missing. The reason for this is because the University of Arizona record does not have the annual revenue field populated. So what we can do to display this is by going to the Options tab and check this Overwrite target for all null inputs option. And when we come back here and execute it again, we can now see this attribute. So checking Checking this option basically allows any attribute mentioned in the output JSON path be available as a JSON output, even as an empty value. So in most cases, you would actually leave this option unchecked. The reason for that is that for one or two accounts, it might be okay to send through some empty fields. But once you have thousands or millions of accounts, things can add up quite quickly. Your JSON can grow quite big if you start sending these empty fields or attributes. So best practice is to only send what you need. Let's say now you have a new requirement and you want to display all the account details on the website via a flex card so your potential customers know who your customers are and know the details about these companies. So what you are thinking is you want to build a DataRaptor that fetches all the account and associated details for you. So what we can do is we can go to the extract. What we are doing is we want to make sure we are fetching all the accounts with an ID basically. So we'll go accounts ID doesn't equal to velocity null. So let's give this a go and run it. And we don't actually need this anymore though, so let's get rid of this because we don't have a variable in the query at the moment. And when we look at the query, it's select account number, phone, annual revenue, name, ID from account where ID isn't null. And now we can see all the accounts in the system. And if we want to limit this to 5 accounts, what we can do is we can just go limit 5 and preview tab and hit execute. So I want to spend some time on JSON as this is quite important, especially if you are doing the OmniStudio developer exam. Notice how the entire response JSON is wrapped inside an open and closed curly bracket. Now starting with the accounts node, because we have more than one account records in the result, all the accounts are stored inside an array, and this is presented by the open and closed square brackets. Each account record is stored inside the curly brackets, and between the account records, these are separated by a comma. So the response JSON here is actually matching with what we have configured over here in the extract tab. The JSON is wrapped inside the curly brackets, followed by the JSON node accounts and the array square brackets. And for each individual records, they are in their own curly brackets. So now if we limit this to 1 and hit execute, you'll notice that the square bracket is now gone because there is only now one record. So we don't need an array if it's just a single record. And if we look at what's in the output tab, this is basically matching with what we've got on the response now. So you can use this current JSON output as a way of visualizing how the response will look like if it's just one record. Now let's change the spec because what I want to show next is I want to be changing the JSON path around. So for example, if all the fields are currently inside the accounts node, and if we take the accounts node out for the phone field, notice how the current JSON output is now different. all the fields are still wrapped inside the accounts node apart from the phone field. The phone field is sort of by itself outside the accounts node being in the open. So if we hit execute, this is what we are expecting. Each individual record will be looking like this, where you have the accounts node with the 3 fields and this individual field being left out in the open. So this is looking quite messy and will be quite difficult to be used by other OmniStudio tools like your OmniScript integration procedures or FlexCard. So it's not good practice. So let's just change the spec. But what I want to show is that it's possible to customize the output JSON path to whatever you want the structure to be. So let's add the spec and execute. And now this looks a lot better. So I want to spend a bit more time on the output tab. Let's have a look at what we can do with the output data type. So by default, if you leave this blank, it automatically pick the data type based on the field type. So for example, the account number will be the text data type by default. Annual revenue will be currency, name will be text, and phone number will be phone. You can find the data type, of course, in the object manager. And if you want to change the output depending on the output data type we choose, we need to select an option over here. So for example, for annual revenue, if I want to change that to, so at the moment it's currency, right? Without the quotation in the result. So you'll see because it's currency, it doesn't need the quotation mark. If I want to change this to a string, select the string over here. And if we execute now, this will be quotation mark will be added because now it's actually a string. So sometimes that might be a useful function to have to manipulate the output data type through this way. And the other thing I want to show is that if we, for some reason, let's pick the wrong data type, we'll just change the spec. What can happen is that, so for example, if for name, if I pick a different data type, let's say integer, so that's it, what happens. So at the moment, account name is text, and when we try to change this to integer, it becomes null. So this happens when you pick the wrong type. It will basically display anything invalid as null. Let's now have a look at how we configure the default value in the output tab. So for each of these output field, we have the option to select a default value. What this means is that if a field is empty or lacks data, the default value will be applied instead. So let's take this account number, for example. Currently, these accounts do not have the default value applied for accounts number because they contain data in the account number field. So let's illustrate this by modifying the Edge communication account record and make the account number field blank. Let's now remove the account number for Edge communications. Click on Save and come back to our DataRaptor and let's set a default value as 1, 2, 3, 4, 5 and hit execute again. So upon executing the DataRaptor again, the default value we set will now be applied to edge communications. What if you have a new requirement on the website? You want to show all the customers that you are working with and also the contact details of the people who are working for these companies so that your potential customers can contact them for reference. So you have a flex card designed and you want to build a DataRaptor extract to feed the data into the flex card. So let's create a new DataRaptor. In this DataRaptor, we will be extracting account details and contact details. So I've named that the extract ext account contact details, and we want to go with extract and keep the rest as default. So let's start by fetching all the account records. Select accounts. For the JSON node, again, let's go with lowercase and plural to distinguish from the actual object itself. To get all the accounts, we need to make sure the ID is there by using velocity.null with quotation mark and output. Let's start with accounts name, copy paste this to keep a differentiation to the actual field name. Let's keep it lowercase and check the current JSON output so that this looks good. We've got the accounts node with the name attribute here. Let's execute, and we are not getting anything here. I suspect it's to do with this. Let's fix this and hit preview again. And now this looks a lot better. So yeah, when you're trying to get all the accounts, it's quite important to get the capital correct as well. So starts with capitalized V, capitalized N. So now we are getting all the accounts and the names, and the query looks correct. Select name ID from account where ID is not null. We can now start working on getting the context. So to get all the context associated with the account, we need to add another step. Start with contact. Again, we'll keep it lowercase and plural. And this is the interesting bit. We want to get the lookup field on the contact where this account that appears on this lookup field is what we are fetching over here. So to help you understand this a bit better, let's first go to the record itself. If we go to Bob, we can see that there's this account name field. So this is the field that we actually want to get for all the accounts. And to get the API name for this, the easiest thing is to obviously go to the object manager, and here we go, account name. So what we need to get is the account ID field. So the filter here will be the account ID, and we want to have all the contexts that are associated with the accounts that we are fetching. So the easiest way to do this is we have the extract output path where all the query results and associated fields are stored under the accounts node, and we want to get the account ID here. And if we look at the extraction step here, the accounts are still in separate JSON with context, but I'll get into this in a bit. So this is not exactly what we want, but we'll get to it after we see how the preview looks like. So for now, let's just get the first name from context. First name, and again in the output JSON path, we'll keep this lowercase. And again, when we look at here, it's not exactly what we want, but we'll get to this in a bit. And let's hit preview. So now we are fetching all the contexts, and we're also fetching all the accounts. But this still looks a bit off, as ideally we want the context that belong to the accounts to be basically in the same section. And if we look at the query, you'll notice that there are two queries over here. First one is the getting all the accounts part, which is this part. And this basically gets all the accounts. The second query we are running here is select account ID, first name, name ID from contact, where ID is equal to all of this that we fetched and stored under the accounts node. So that's why you are seeing all these account IDs and or statements is to get all the associated contact details under each account. So what we actually want is that for each of these account records inside the open and close curly brackets, we also want to have the context node inside here as well, or contact nodes, depending on how many associated contact records there are for each account. So let's go back and fix this up. So to fix this up, we need to fix the JSON structure. And just to reiterate what this is doing, again, is the first step is getting all the accounts. Second step is getting all the contexts, where the account ID is equal to the ID that you get, or the account record that you get from the first step. So to move the contacts node inside the accounts node, what we need to do is we need to introduce another container or another node above the context node. So the best way to picture this is that at the moment you have the accounts container, and which you've set up in the first step. And second step is that you want to put all the results that you are fetched for the contact records inside the context container. But this context container is actually inside another container called accounts. And if we look at the extraction step JSON, this is looking a lot better, where we have the top JSON node as accounts, and within the accounts node, there's the context node. So if we just go ahead and click on preview now, what you'll notice that is that this doesn't look quite right. We can only see the name of the accounts, but not context. And the query here actually hasn't changed. We're still getting all the accounts here. We're still fetching the context for each account as a second query. So the reason for this is, as we've changed the extract output path here, now all the query results are being stored in a different path now, so a different container now. So what we need to do for this for this response to work is that we need to return to the output tab. And we need to update the extract JSON path and output JSON path as well. So at the moment, it's still extracting contact records and the first name field from the context node, but this path over here is actually not valid anymore, because now all the contact information is actually stored inside accounts context. So if we just copy paste this and come back to the output tab and replace this with the current extract JSON path, and also update this as well with the same output JSON path so that the output will align. And actually, I'll just leave this out for now so we can see what the difference is. So if I don't make changes to this, the current JSON output wouldn't look correct. But when we go back to the preview tab and execute it again, I'll now be seeing all the contacts and accounts. And the reason why we are seeing it now is because we have updated the extraction JSON path to match with what's being configured over here. So now the data we are extracting is coming through. But the output JSON path is still not quite there. So what we need to do to bring the context node into the accounts is that we need to add the accounts node as the top node. And what this will do is this will bring the context node inside the accounts node. And when we go and preview this again, this will be what we are expecting here. So this is quite important, what I've just demonstrated there. In the developer exam, you'll need to know how to set up the extract JSON path, output JSON path, and what the result will look like. So let's actually spend a bit more time on the response. Again, I know I've covered this in the past, but it's quite important that we keep going over this again and again to get you familiar with how the JSON structure will look like. So starting with the accounts node as the top node, and this is followed by an array because we have multiple accounts. And what we can see here is that the first account is called Edge Communications, and within this account we have context, which is shown by arrays to indicate that there are multiple contexts, in this case 3 contexts. And we also have another account called Burlington Textiles Corp of America, and inside and under this account there is only one contact, and hence we don't see the square brackets because it's not an array, as there's only a single contact called Jack. Now let's go back to the output tab, and I want to just add another field over here for the accounts rating, keeping this lowercase, and let's just run it. And now you can see the rating field on each account now. So what I want to demonstrate is that in your outputs tab, there's the output, there's the transform map values. And this transform map values, you have the key and the value, what you can think of as it's like a search and replace in Word. So as example, if the rating is hot, I want this to be replaced with super hot. And you can add multiple of them as well, but let's stick with one for now. So if we go to preview and execute this again, you'll notice that this hot rating will be changed to super hot. And we can move warm to something else as well by adding another key value pair. Warm becomes super warm. And yeah, there you go. That's how you utilize the transform map values function. And let's have a look at how this actually works in detail. So what this is actually all saying is that we are extracting value from the accounts node and the field is rating. And if what we've extracted in terms of value is hot, then we replace this with super hot and output it in the accounts node um, and the rating attribute. So this is what we are basically doing over here. Let's now have a quick look at how we can use the quick match option. So this option here is to help speed up the mapping process. So what we've been doing so far is be doing this manually one by one for each field. But a lot of the cases, you should already know what the expected JSON would be. For example, if you are using if you are using the DataRaptor extract to extract data from account and context, and you are passing this JSON data into the OmniScript in order to prefill it, you should already know what the OmniScript will be expecting in terms of the JSON requirements. And I'll actually be doing a quick demo on that in later part of the video. So this will make a lot more sense when I demo how this actually talks with the OmniScript. But for now, let's copy paste this. And actually, before we do that, to make things slightly easier, we don't need to do this, but for now, we'll just limit the result into just one single account. So the structure looks a lot tidier and easier to understand. So now let's copy paste this and let's paste it in the expected JSON output. And actually, before we pasted this, let's just clear this JSON output first by deleting all the mapping we've got so far, just to demonstrate this quick match functionality. So now with this current JSON output being empty, let's now paste our expected JSON structure over here. And now this is still empty. And now if we go to the quick match, you'll notice that the output mapping is already there. And this is based on what we have provided in the expected JSON. So account context first name, accounts context first name, accounts name, and accounts rating, And on the left here in the input mapping, we have the accounts node following by the account field. We also have the account context node followed by the contact field. And usually all these options would appear when you do it manually. So these are all the options that you are seeing on the left hand side of the quick match screen. And on the right hand side here, the output mapping is what you usually have to do manually in the output JSON path. So now let's click on the auto match button, and you'll notice that the output mapping is now gone, and you probably wouldn't be able to tell, but 3 of the input mapping is already gone as well, as this is being matched automatically. So now you can see the first name field from context is now being mapped to the first name field on the account context node, and this is in lowercase. This is where it becomes important, because we've named it lowercase, it's a lot easier to tell from the actual field API name apart. And same with name and rating. So if we click save, You'll notice that these three have been added automatically. Let's just ignore this one because we were just demonstrating how this manual process matches with the automatic process. And you can see now the expected JSON is appearing and was the same as before. Oh, sorry, it's the wrong place. And now you can see the current JSON output is not appearing and was same as before. It's the same as before how we were adding it manually. And let's hit execute again. And we'll just remove this limit and hit preview. And now again, we are seeing all the accounts and all the context associated with the account. So let's go back to the output tab. I just want to spend a bit more time on these tabs, these three tabs over here. These are quite important if you are sitting the developer exam. So extraction step JSON is basically how the data will be coming. You can think of this as the source, and this is what you have basically configured in the extract tab, and it's also shown over here as well. The expected JSON format is how we want the JSON structure to be, and by putting this in, it allows you to do quick match and speeds up the mapping process. And the current JSON output is the actual data output based on the mapping that you have configured over here. Another thing that I want to also show is that we don't necessarily have to use the quick match option. And the way to do that is that let's just delete all of these for now. And now the current JSON output is empty. What we can also do is that we can also do this manually, but because we've put in the expected JSON output, it will be a lot easier. So we are still getting the rating field from accounts, but what you'll notice here is that see these three options are already there without us having to do any manual inputs in the output JSON path. And this is basically gathered from what we've inputted here. So we can map in rating, and it'll be the same with the name as well. If we go to accounts name, over here the option is already there, and let's do it for first name, and same here. The output JSON path is already there based on the expected JSON output we've put in. And now if we click on the current JSON output, it's the same as before. And if we hit preview, we are getting exactly what we were getting before. So I also want to show this as well. You might have a scenario where in the OmniScript, instead of rating, the OmniScript is expecting customer rating as a requirement for the JSON data, but what this customer rating needs in the OmniScript is actually the rating field on the accounts. So what will happen is if we put this in the expected JSON output, and let's just get rid of all of this again, and check current JSON, it's now empty. If we click on quick match and auto match, what you'll notice here is that we are not getting a match for customer rating because there's no match in terms of the spelling. You only get a match if the spelling is the same. So first name here, first name, name, and name. So what we'll need to do here is we'll need to do it manually. So click on rating, drag and drop, and now it's appearing on the matched mapping. So we're getting the information from the rating field from account, and we are mapping it to the customer rating attribute under the accounts node. Click on save. And now you'll notice that the current JSON output is now what we are needing here to provide to the OmniScript. So we click on preview and execute, and now these are all changed to customer rating. So let's work on our next DataRaptor extract. The scenario is that we want to retrieve all contact data that includes the name of the account with which the contact is associated with. And we also want to fetch some of the values from this account record. So there are actually three ways to achieve this: to fetch the contact record and the associated parent account details. So what I'm referring to is, for example, let's take Sean, the contact record, for example. We want to fetch the account name, and we also, from the account associated account record, we also want to fetch some details here. For example, the rating, the website, the industry. So option number one is to actually use a DataRaptor turbo extract, as you can fetch details from a single object and also the associated parent object, which is account in this case. So this actually has the best performance at runtime. However, if you need to use formula to manipulate data, for example, if you need to use formula to manipulate data in the department field to replace finance with accounting, as example, then you have to use DataRaptor extract, as DataRaptor turbo extract does not support formula function. So within DataRaptor extract, we can actually achieve this in two ways. We can achieve this using multiple extraction steps or using a single extraction step with relationship notation. And which one do you think has better performance and runtime between these two options for DataRaptor extract? It's actually the single extraction step with relationship notation option, as it only requires one step, meaning it only requires a single query. So we'll cover both options in detail, but now we will cover the multiple extraction step first, and we'll follow by covering the relationship notation, and we'll do a comparison between the two. So if you are studying the developer exam, this is super important that you understand this concept of relationship notation. So starting with the multiple extraction step option. So for the name, we'll go with dr extract contact details multi-step. We'll be using extract DataRaptor, keep the same for the rest. So we want to first by getting all the contact records. Select contacts, select contact as the object, and for output path, keep a lowercase plural. To fetch all the contacts, we'll go id is equal to velocity.null. And for output, let's start with the first name and keep this lowercase. And also we want to fetch the last name as well. Keep this lowercase. Execute. So now we've got all the contact with their first name and last name. Now what we want to do next is we want to fetch the account field that's associated with all the contacts. So to do this, we need to go to account. Again, keeping this lowercase and plural, where ID is equal to the account ID on the context field. And the way that I know it's account ID is to go to the object manager, and if we go to contact, you'll see that this account lookup, account name with the account lookup has the API name of account ID. So we'll go with the context node because all the query results are stored in this node. Context account ID. So what this is basically saying is that I want to go to the context node and grab the value of the account ID field and extract the account based on this account ID field that we have extracted from this context JSON node. So now let's go to the Outputs tab and let's get the account number. Again, good practice is to keep this lowercase so we can tell from apart from the actual field name. And we'll also get the account name as well. Account name, keeping this lowercase. When we hit preview, now we are getting a bunch of contacts and all the accounts. Now, because we are only getting 2 fields from the accounts, and there's not a lot of fields on contacts, what we can do is we can design the OmniScript in a way that it takes all the fields under a single node. For example, if we want to combine first name, last name, also the account number and account name into a single node called person, what we can do is we just go to the Outputs tab and replace everything, all the nodes with person as the top node. And what this will do is that instead of having the account and context node, now all the fields will be stored under a single node, which will be easier to handle from the OmniScript side in this case because it's a simple scenario and there's not a lot of fields. And if we hit execute now, you will see that this record is Bob Young, name is Edge Communication, and it's missing the account number field because it's empty. For this Burlington record, we do have the account number field, and same with the rest as well. Now let's have a look at the debug log. What you are seeing here is we are running 2 queries. This is the first query over here. This is to do with the this is to do with the contact object, which is from step 1 in the extract tab. And the second query over here is on the account object, which is corresponded to step 2 over here. So what we're seeing here is for this first query, we are getting the account ID, and this is actually coming from this over here, where we're getting the account ID from the context node. First name is coming from the output tab where we've configuring a way that we are fetching the first name, and you'll see the last name over here as well. And by default, because we are fetching first name, last name, we also get the name of the contact and ID as well. For the second query over here, we're getting the account number, which is what we've specified over here. Name is default, ID is default. And this where, but the reason why we are getting a big where section and in between the IDs is the or operators, because we are getting all the account records where the ID is associated with the ID on the account lookup on the contact records. Now let's build the other DataRaptor that we talked about, which is using a single step and utilizing relationship notation. So let's name this the extract contact details single step and keep the rest the same. So similar to the multiple step example, let's start by getting all the contact records. Contacts ID not equal to velocity.null with a $sign in front. And let's also get the first name. Keep it in the person node as well, same as the previous example, and keep this lowercase. And we'll do that with last name as well. And this is all looking good here. Let's hit preview. And this is the same as what we've configured in a multiple step here. So yeah, you can see the output mapping is the same. Now here comes the critical part with the relationship notation, how we can use them. So you might be wondering what a relationship notation is. So what relationship notation is that basically it's based on relationship queries in Salesforce. So for example, what we are trying to achieve at the moment is from the contact object, we're trying to get the name from the account and also the account number from the account field. They are associated with the contact record. So this query basically shows how you use the relationship notation. You start with the parent object and followed by a dot and the field from the parent object that you want to fetch the data from, and this is what the result looks like. So this is pretty much what we are trying to achieve, but what we'll be getting with our DataRaptor is that it'll be in a JSON format. So let's now go back to our single step DataRaptor extract and start utilizing the relationship notation to get the account number and the name. So again, starting with context, and now we'll be using the relationship notation. So let's get the account name first. And notice how this option is actually not available in the extract JSON path. So what we need to remember is that in extract JSON path, not all the options will be there, especially for relationship notation. For relationship notation, you'll need to enter them manually. It's gone. Let me just do it's back here now. And for output JSON path, again, we'll be putting it in the person node, account name, and yeah, this looks good. And we'll do it for account number as well. So context, add this here, put it in the person JSON node, account number. That looks good to me, and let's run it. And we're now getting basically the same result as the multiple step DataRaptor. But the only difference is that notice how in here, in the single step DataRaptor extract, there is only one query, which is select name, account.name ID, account.account number, last name from contact, where ID is now blank. But comparing this to the multiple step one, where there are two queries involved. So one important thing to remember is that using relationship notation improves the performance of DataRaptors that retrieve data from a parent object of the primary Salesforce object. So you use this notation in the extract JSON path for the parent object fields instead of adding a second object in the DataRaptor extract tab, like how we have done it in the previous one where we've added another step to extract from the account object. So let's go back to the single step one using relationship notation. One very important thing I want to highlight is that for relationship notation, you need to use the dot to access the attribute, whereas for accessing JSON structure, it's a column. So this is quite important if you are sitting the developer exam, making sure you know the symbols. So we've talked about using notation, relationship notation in the outputs tab. We can actually use this in the extract tab as well as one of the filter conditions. So let's just add this, and we want to get it where the account name is like, let's say, H. So same story over here for the relationship notations. It's not going to automatically appear in the options like all the fields under contact. For relationship notation, you need to enter these manually. And we'll keep the rest the same and execute. And now, because we've put another filter over here, it should only be showing context where the account name contains the word edge. And that's exactly what it's showing over here in the where statement, account name like edge. Now let's build another DataRaptor together. This DataRaptor will be learning how to use the formula tab. Let's name it DREXT account details with formula. Let's first fetch all the account records, store this under the accounts node. To get all the accounts records, we need to fetch all records with velocity.null. And for now, let's keep it simple. We'll just display the name of the accounts for now, keeping this lowercase so that we can identify the difference between the actual JSON attribute and the object field. Preview, and now we can see all the account records and the associated account name. Now let's say you have a scenario where on your website, you have a flex card, which is getting data from this DataRaptor extract. And on your flex card, you want to display all the account names. But the difference is that you want to display name in a way that every single account name is appended with limited. So for example, Edge Communications, on your flex card, you want to show Edge Communications Limited. So how do we actually go about doing this? Let's now head to the Formulas tab. To add a formula, simply click on this button. And as you can see here, you can add multiple formulas here. And on the right hand side here, you have the extraction step JSON. This is the same step JSON as you see here. So the reason why there is a section here is that this will actually help you to write the formula. For example, if we want to concatenate all the names with limited, what we can do is we can show all the S object fields, and we're looking for the account name, which is this over here, and we know that the account name is stored under this node. So in the formula section, so this supports all the standard Salesforce formulas like concat, and this is the one that we need. Let's get rid of this, and what we want to concat is the account name, which is stored in the accounts node. We want to leave it a space between limited and the account name. The formula result path specifies the JSON node that stores the data with the formula applied. So what we'll do in this case is we'll go with accounts, and we'll go with name with limited as example, and here you can disable and enable the formula. So if we go ahead and just hit preview now, you'll notice that nothing has happened. The reason for that is because even though we have a formula result path that stores our manipulated data, we still need to map it here in the output tab. So we'll keep this, and what we'll do is we'll take the manipulated data and we'll store it on the account name updated, for example. And now I can see this new attribute appearing over here. And if we hit execute again, you'll see that we have a name, which is Edge Communications, and we have the name updated, which is Edge Communications Limited. So that was just an example to show you how the formula basically works. So this is actually quite important as well. If you are sitting the Salesforce developer exam, you need to know about the formula result path and how you can map this in the output so that it would display the manipulated data in the response. So let's tidy this up a bit. So we only want to show the name updated data, and we want to keep the attribute as name. So to do this, let's just get rid of this. And what we can do is we can actually just change this to here. So what that is doing is when the data gets manipulated, it'll store under this path, and this path will be mapped over here as the extract JSON path. So the extract JSON path will basically fetch the manipulated data and map it to the JSON, the output JSON path. And if we hit execute again, now this looks a lot tidier. Alright, for this part of the video, we're gonna be briefly going through how DataRaptor extract can be used to pass JSON data that the DataRaptor has extracted to other OmniStudio tools like OmniScript. So don't worry if the OmniScript part doesn't make a lot of sense, as we haven't gone through it in details yet. I'll be doing that in the future videos. So for now, just follow along. So what we are building here is the online support form on the company's portal. If the customer is logged in, they'll be able to submit a request form. And on the request form, there are questions about the account information, questions about what support that you need. And what we're doing here is we are using the DataRaptor to extract account data so that the customers wouldn't have to enter those again. You'll be pre-populated. This means that the customer will have a better user experience and only need to fill in information regarding to the actual support that they need. So the first thing we'll do is we'll drag in the DataRaptor extract action, and we'll be reusing the DataRaptor extract that we've just built to extract the account name with limited appended to the end. And we'll just come back to this so we can display a few more fields. We'll have the account number, keep it lowercase. We'll also grab the annual revenue. And let's execute this again. So most records have an account number apart from Edge Communications, but that's okay. Let's also grab the ID as well. Execute. Now let's just keep the account JSON simple and limited to one account for now. So it's easy to build the OmniScript. So we'll just limit this to this particular ID, and here we go. So this will give us the annual revenue, account number, ID, and name for this Burlington Textiles Corp of America Limited. Now let's go back to the OmniScript. So what we want to do first is that to check if the data is being passed to the OmniScript successfully. So if we click on preview, what we should see here is the same JSON node as we are getting over here. So all the fields and everything is stored in this accounts node, with the attributes being in lowercase. So what we want to do next is we want to design our OmniScript in a way that has the right JSON structure, so these data they go to the right places. So let's go back to the design view, and for the first page of the form, the name over here, we'll need to name it accounts as this top node, and for field label we can have it as account information. So this is what will be shown to the user. And what we want to do to display this information is that we need to drag in some boxes, starting with the name of the account. So the API name is not the API name, the name of the attribute is just name. And for the field label, we want to be a bit more descriptive, which will be account name. We'll clone this and we'll display the account number as well. Account number, and for revenue, it's a number field, so we need to use this. And again, copy the any revenue attribute across to the name, and let's hit preview. And there you go. This is all pre-populated based on the JSON that's been passed from DataRaptor extract. So now if we go back to the form, we can, have a second step, and this step can be support details, and here we can just put in some placeholder fields like description, and to keep it simple, let's just have one field for now. So when imagine the customer logs onto the portal, they'll see this is already being populated. They click on next, they can start entering their support details. Need help with, and as I'm entering details here, you see this is automatically being entered as well. So don't worry if this is confusing. When we get to the OmniScript session, I'll be explaining this in detail and some of the best practices in passing data between DataRaptor and OmniScript. And we'll also talk about how we can design in a way that the DataRaptors become reusable, because at the moment, from this example, it's quite restrictive because we need to name these in a way that matches with the DataRaptor. But what I'll be covering is ways of designing the DataRaptor so that we can use some of these functionalities like input parameters and response transformation so that everything we designed in OmniStudio is reusable. And what this means is that you can have a DataRaptor that fetches all the account details with different JSON structures, but we'll be able to set it up in the OmniScript in a way that accounts for different JSON structures in your DataRaptors. So you don't need to end up designing a DataRaptor for every OmniScript. And instead, in this example, you'll just have a DataRaptor extract that will extract all the account details. And this DataRaptor will be shared for all of the OmniScripts that need account details extracted. So as promised, I've designed 3 challenges for you to help you check your understanding. So these exercises are quite important, especially if you are doing the OmniStudio developer exam. It's important that you can do all of these. So feel free to put your response or your query in the comments below. I can go over those for you. And feel free if you have any questions regarding these challenges or anything that's mentioned in the video as well. So challenge number 1, use DataRaptor extract to fetch all case records and the following fields and order the records by case number in ascending order: ID, case number, description, priority, reason, status, and subject. Challenge number 2, use DataRaptor extract to fetch all case records and the following fields and order the records by case number in descending order. use the formula function to append case number with priority, for example, 004422-high. ID, case number, description, and priority. Advanced. Use DataRaptor extract to fetch all case records and the following fields where the industry field on the associated account is equal to electronics. Use relationship notation and single extraction step. ID, case number, industry from account object, name from contact object. And good luck. So to recap, if you've watched my earlier videos on DataRaptor overview, where I've described each DataRaptor in dinosaur images, this one here is a DataRaptor extract chef where it's capable of preparing for multiple ingredients. So it's got the ability to get data from single or multiple objects. It can support formula, and best practice is to use DataRaptor Turbo Extract when fetching data from single object or parent objects when formula is not required. So I hope you've enjoyed this video and learned a few things about DataRaptor Extract. I know this is quite a long video, so I will encourage you to go over this video a couple of times to really get familiar with the concepts. And that's it for today's video. Please like and subscribe as I'll be making more OmniStudio related videos in the upcoming weeks. And turn the bell on as you'll get notified when new videos come out. That's it, bye!